Hi everyone, today we are going to talk about the rotation of conics. So what we have been doing so far with conic sections is graphing equations in this form. So we have terms that have x squared, y squared, xy, and we have constants, but you might notice that we don't have any terms that have xy. So you might also notice that we're missing that b coefficient. So that's where the rotation comes in. Whenever you have an equation that has this xy term, we know that we're going to have a graph that is not parallel to either your x or your y axis. So we're going to need to find a way to address this rotation. So essentially what we're going to do is we're going to take our equation and we're going to find an angle for rotation of our axes, so rotation of axes. And then we're going to find a way to rewrite this equation in terms of our new x prime, y prime axis. And our new equation, when we go through that process, should no longer have an xy term, and everything should be in terms of x prime and y prime. From there, we can treat it as a normal equation, put it into standard form, and graph it, except now instead of graphing it on the xy axis, we're going to graph it on this new x prime, y prime axis. So there are some formulas that you need to know in order to do this rotation of axes. So first of all, remember we're starting with something like this and we want it to turn into something like this. So the first thing we need to do is find that angle, the angle of rotation, and we can use that, find that with this formula. Cotangent of 2 theta equals a minus c over b. And the a is going to be the coefficient of x squared, c is the coefficient of y squared, and b is the coefficient of your xy term. So that allows us to find theta, and then we're going to use these two formulas down here to substitute for x and y. So x we're going to replace with x prime cosine of theta minus y prime sine of theta, and y we're going to replace with x prime sine of theta plus y prime cosine of theta, and that should allow us to eliminate that xy term. So we should end up with something that looks like this, which we can figure out from there what type of conic section is, and we can graph it on our new x prime, y prime axis. All right, so let's give this first one a try. So we have xy minus 1 equals 0. So I know this is going to be a rotated conic. So first we need to find theta. So our a value is 0 because there's no x squared term. Our c value is 0 because there's no y squared term, and our b value is 1. That's the coefficient of our xy term. So I can use our formula, cotangent of 2 theta equals 0 minus 0 over 1. So the cotangent of 2 theta equals 0. So we know that the cotangent of pi over 2 is 0. So 2 times theta is pi over 2, which means theta is pi over 4. So this is going to be the angle of which our xy axis is rotated. And I'll show you what that looks like farther on in the problem. But from here, now we need to rewrite this equation in terms of x prime, y prime, and we need to eliminate this xy term. So remember, we do that with substitution. So we're going to replace x with x prime cosine of theta, which is pi over 4, minus y prime sine of pi over 4, and we're going to simplify. Just a little tip, I know that usually we say that the cosine and sine of pi over 4 is root 2 over 2, but in this case it's actually easier to use the non-rationalized version, so we're going to call this 1 over root 2 and 1 over root 2, which gives us x prime minus y prime over root 2. It's going to be easier for us to simplify later on. So then we use that formula for y, which is x prime sine of theta plus y prime cosine of theta. And what we end up with is y equals x prime plus y prime over root 2. Okay, so now I'm going to take both of these values and I'm going to substitute them into our original equation. So I'm going to replace x with this, and I'm going to replace y with this. And what we get is x prime minus y prime over root 2 times x prime plus y prime over root 2, and I'm going to move that -1 to the other side. All right, so now we just need to multiply it out and make sure that all of our xy terms have fully disappeared. So I'm going to do essentially FOIL. So we have x prime squared, and then we have plus x prime y prime minus x prime y prime, and then minus y prime squared over 2 equals 1. So at this point, now I look at it and I see xy has disappeared, so that's good. And now I want to write it in terms of standard form, and I see that this is actually a hyperbola. And we're going to start listing out the different characteristics just like we would any other hyperbola. So this hyperbola has a center at 0, 0. The a value is root 2, the b value is root 2, and the c value is 2, which means that our vertices, since it's horizontal, will move left and right. So our vertices are at negative root 2, 0, positive root 2, 0, and our foci are at 2, 0, and negative 2, 0. Now the thing to remember is that these are not coordinates from our xy axis. These are coordinates from our x prime, y prime axis, which we're going to talk about right now. So here's the equation that we're going to be graphing on the x prime, y prime axis. So let's we'll start with a normal xy axis like this. Okay, so this is x and this is y. But remember, our angle of rotation was pi over 4. So I'm going to take this and I'm going to rotate it clockwise pi over 4, which is essentially, well, it's just half of a quadrant. So this is going to be x prime, and this is going to be y prime. So this is the axis that we're going to graph all of this information on. And so I recommend tilting your paper, making this vertical and this horizontal. Now we can still give these like units, like we can say 1, 2, 3, 4, -1, -2, -3, -4, so to help us plot our points. So I see that the center on the x prime, y prime axis at 0, 0. My vertices are at root 2, 0 and negative root 2, 0, which is somewhere between 1 and 2. So maybe right here and right here. I know that it's going to look something like this. And I know that my foci are at 2, 0 and negative 2, 0 on the x prime, y prime axis. So here you have it. This is our rotated hyperbola. So remember, all of these coordinates are in terms of the x prime, y prime axis, which is just right here. Now we can take any of those coordinates and rewrite them in terms of the xy axis. So I just want to show you how to do that with one of them. So let's take one of our vertices. Let's take, in terms of the x prime, y prime, one of our vertices is at root 2, 0. What if I wanted to know what this coordinate is in terms of the normal xy axis? I can actually substitute these values to get my x and y values. So if I substitute for x, I get x prime, which is root 2, minus y prime, which is 0, over root 2. So the x value is 1. For y, I get x prime plus y prime over root 2, which is also 1. So actually, this coordinate on the xy axis is at 1, 1. So you can take any coordinate from your x prime, y prime axis, plug in the points here, and you can get the coordinate on the xy axis. However, that's not always going to be a helpful thing for us to do. Typically, we just want to graph everything in terms of the x prime, y prime axis. Okay, go ahead and pause the video and see if you can give this problem a try. Okay, I'm going to go through the different parts. So first, make sure that you get the correct angle of rotation. So theta should be pi over 4. And then the x value substitute should be x prime minus y prime over root 2. Y you should substitute with x prime plus y prime over root 2. And we substitute both of those into our original equation, multiply it out, and simplify or put it into standard form. And here's what you should find. You should find that we have a hyperbola that is vertical. Our center is at 0, 0. Our A values and B and B, our A, B, and C values are listed here. So our vertices are at 0 plus or minus 2 root 3, and our foci are at 0 plus or minus 2 root 6. Now all of this is in terms of the x prime, y prime axis. So you can see here, this is my y prime axis. So here's 0, 2 root 3, here's 0, 2, negative 2 root 3. And remember, this is just some number between 3 and 4. So you should be between the correct two integers. Now, our foci are also listed, and this is about as much as I would expect you to be able to do. So once again, all of these coordinates are in terms of your x prime, y prime axis, which has been rotated by an angle of pi over 4. All right, let's try another problem together. This one we start off the same. The multiplication or the work to simplify and put it into standard form is a little more extensive, but we'll get through it. So let's start by finding our theta. So cotangent of 2 theta is A minus B or minus C over B. So I can see that it's negative 6 over negative 6, so it cancels out. And just to make it a little bit easier in evaluating, let's use the reciprocal function. So I know that the tangent of pi over 3 is root 3. So 2 theta is pi over 3, which means that theta is pi over 6. So that's going to be our angle of rotation, and now we need to figure out what to substitute for x and y. So we have x equals x prime cosine of pi over 6 minus y prime sine of pi over 6. So x is going to be, so the cosine, remember that the cosine of pi over 6 is root 3 over 2, sine of pi over 6 is 1/2, so we have root 3 x prime minus y prime all over 2. Now let's do the same for y. Y we are going to substitute with x prime sine of our theta plus y prime cosine of theta. So y is going to be x prime plus root 3 y prime all over 2. So I'm going to make those substitutions. I'm going to highlight our important information. I'm going to make these substitutions into our original equation. So I'm going to zoom out a little bit here. We're going to have 7 times our x value squared, so root 3 x prime minus y prime over 2 squared, and then minus 6 root 3 times x times y and then plus 13 times our y value squared, and then I'm going to move that 16 to the other side. So now here we actually do need to go through the process of multiplying this out, and this can get a little bit lengthy. However, you just need to remember it's just multiplying binomials, which you're totally capable of doing. So I'm going to start with that first one. I'm going to keep the 7 on the outside. This will give us 3x prime squared minus 2 root 3 x prime y prime plus y prime squared. And I'll distribute that in later. I'll take care of the denominator at the end as well. And then we have minus 6 root 3 times, if we multiply those out, we get root 3 x prime squared, And then here we will get plus 3x prime y prime minus 1x prime y prime. So we get plus 2x prime y prime minus root 3 y prime squared. And then last, we have plus 13 x prime squared plus 2 root 3 x prime y prime plus 3 y prime squared. Sorry guys. There we go. Equals 16, and all of this is going to be over 4 on the left side of our equation. All right, now we're going to go through the process of distributing in our coefficients. So we have 21 x prime squared minus 14 root 3 x prime y prime plus 7 y prime, there we go, squared. And then here we have minus 18 x prime squared plus, minus 12 root 3 x prime y prime plus 18 y prime squared. And now we just need to multiply out that last part. So here we'd have plus 13 x prime squared plus 26 root 3 x prime y prime plus 39 y prime squared equals 16, and of course all of this should be over 4. So now at this point, we're going to go through and make sure, the first thing we're going to check is that our x prime, y prime terms have canceled out. So if you look for all of our x prime, y prime, we can see that here we have negative 14 root 3, negative 12 root 3, and positive 26 root 3. So they do in fact all cancel out. Which is good. If they don't, then we did something wrong. So now we're going to want to combine our other terms. So here we have 21 minus 18 plus 13 x prime squared. So that gives us 16 x prime squared. Then we have 7, 18, and 39, and that gives us 64 y prime squared all over 4 equals 16. And we can see, oh, nice, we probably have a nice ellipse equation here. So let's put it into standard form. I'm going to start just by dividing out that 4. And then to put it into standard form, you're going to divide both sides by 16. So we have x prime squared over 4 plus y prime squared over 1 equals 1. So I can see that here we do in fact have a horizontal ellipse. And let's describe what we know about this ellipse before we go and graph it. So we know that the center is at 0, 0. Our A value is 2, our B value is 1, and our C value is root 3. So this tells us that we have vertices at plus or minus 2, 0, and our minor axis vertices are going to be at 0, plus or minus 1. And we also know that we are going to have foci at plus or minus root 3, 0. Now remember, all of this is written in terms of the x prime, y prime axis, not the xy axis. So now we do need to go graph it, and we have to make our x prime, y prime axis. So remember, our angle of rotation in this case was pi over 6, which is 30 degrees. So it's a smaller rotation. So this becomes x prime and this becomes y prime, and we can give ourselves some units there to help us graph. Okay, so let's start. Our center is at 0, 0. Our vertices are at 2, 0, negative 2, 0, 0, 1, and 0, negative 1. And our foci are at plus or minus root 3, 0. And remember, root 3 is somewhere between 1 and 2. So there you have it. We have our rotated ellipse. Now, I do want to remind you guys that while it does look like a lot of work here, after you get past the initial formulas, it really is just substitution and then multiplication. It's just multiplying out binomials. So that's why I feel very, very confident that you are all capable of doing this if you take your time and you show as much work as you need. But you do just need to be careful because small mistakes are easy to make with these, but it's totally, totally doable. All right, so at this point, I'm going to ask you to pause the video and give this problem a try. Okay, I'm going to go through each part separately. So first, here we have that the cotangent of 2 theta should be negative 1 over root 3. So if it helps, we could rewrite that as tangent of 2 theta using the reciprocal function is negative root 3. So here, since this value is negative, I know that now I'm moving over to quadrant 2. So I know that the tangent of 2 pi over 3 is negative root 3. So that means that theta is 2 pi over 3 divided by 2, which is pi over 3. So you can kind of generalize anytime this value is negative, we know that we're going to be working with an angle in quadrant 2. However, you will be dividing it by 2, which will bring it back to quadrant 1. Now from there, we want to make sure you have the correct substitution values. So check what you're substituting for x and y. And then over here, I substituted those values into our original equation. So here's x squared, here's x times y, and here's y squared. And then I'll zoom out a little bit. Pause the video if you need to check your multiplication. So here I multiplied out the binomials. And then in this step, I distributed in the coefficients and combined like terms. So you could see that we know that at least we're on the right track because our x prime, y prime terms cancel each other out. So that's always good. What you have left from there is what looks to be another ellipse. So you can simplify it, put it into standard form, and we can see that we actually have a vertical ellipse because the denominator for y squared is larger. So our a value is 3, our b value is 1, and our c value is square root of 8, or 2 root 2. So that helps us dictate where our vertices and our foci are as well. Let me list those out for you guys. So the vertices are going to be at plus or minus 1, 0, and then 0, plus or minus 3. And the foci are at 0, plus or minus 2 root 2. And remember, square root of 8 is somewhere between 2 and 3. So your graph should be just about as accurate as this. And just be careful here, we have a pretty heavy rotation, so it almost looks like your x prime is vertical, but remember, this is x prime, this is y prime, so if it helps, just tilt your paper. But there you have it. All right, we're gonna try one more problem together. So here, we're going to start in the same way that we do every single time. We're going to try to find our angle of rotation. So the cotangent of 2 theta should equal a, which is 1, minus c, which is 4, over b, which is negative 4. So we want to know when the cotangent of 2 theta is 3 over 4. Now you might notice that this is not a unit circle angle. So there are different things that we can do here. First of all, I always think it's helpful to draw out a triangle. So if I have a right triangle, we can call this 2 theta. The cotangent of 2 theta is 3 over 4. and then you can use Pythagorean theorem and figure out that the hypotenuse is 5. So the reason why that we would want to do this is because if you think about what is in our formulas to find x and y, x is x prime cosine of theta minus y prime sine of theta, and y is x prime sine of theta plus y prime cosine of theta. So here we actually would like to have exact values for the cosine of theta, and we can achieve those. We can achieve those using the half angle formulas. So I know this is a blast from the past, but I know that the sine of theta can be found by doing the square root of 1 minus the cosine of 2 theta over 2, and we can find the cosine of 2 theta using our triangle. So let's also write out the half angle formula to find cosine of theta. So the cosine of theta can be found using 1 plus cosine of 2 theta over 2. Now once again, these are the half angle formulas. So it's been a while since we've used these, but here you can see how they can be really, really useful. So we can determine that the sine of theta is the square root of 1 minus, if you look at the cosine of 2 theta, it's going to be 3 over 5. And then here we have the cosine of theta is going to be 1 plus 3 over 5 all over 2. So if I simplify both of those, we'll get that the sine of theta is 1 over root 5, and the cosine of theta is 2 over root 5 because it becomes the square root of 4 over 5. And we'll leave these with the radicals in the denominators for now. So we can actually use this to help us substitute into our formulas. So using these, let me highlight them for us. I can substitute them here, and I know what to substitute for x and y. So it's a little bit different than we've done in the previous problems, but here we'll have, since it's times cosine, we'll have 2x prime minus y prime over root 5. And then for y, we will have x prime plus 2y prime over root 5. So once again, I simply substituted these values here and kept our radicals in the denominator because those will eventually cancel out. So this is useful for our formula, but if we want to actually graph this, we will also need to know a decimal approximation for theta so we can at least tilt or have a nice estimate for how much our graph should be tilted. So I'm going to go back up to this equation. We can use our calculator and we can get a decimal approximation. So first of all, I'll say tangent of 2 theta equals 4 over 3. And then I can say that 2 theta equals the arctangent of 4 over 3. So theta equals the arctangent of 4 over 3 over 2 divided by 2. And this will give us a decimal approximation of approximately 26.6 degrees. So at least now we know how to tilt our axis for our graph. And of course, 26.6, the best you can do is an approximation when you're graphing. All right, so now let's go back to what we have found to be our x and y values, because now we need to rewrite our equation in terms of x prime and y prime. So I'm going to substitute those values into our original equation. So here we have 2x prime minus y prime over root 5 squared minus 4 times our x value times our y value. Okay, I'm going to slide over a little bit. And then we have plus 4 times our y value squared plus 5 root 5 times our x value. Oops, sorry, I mean our y value. And then I'm going to move that -1 to the other side. And here is what we're looking at. So at this point, you'd have to go through the process of multiplying all of this out again. Instead of showing it all out, I'm going to ask you to trust me, and that if you multiply all of these out and you combine like terms, what you will get as your simplified version is 5 times y prime squared plus 5x prime plus 10 y prime equals -1. So from here, now I see, well, at least my xy term has canceled out, so now I just need to focus on putting this conic into standard form. So I know that this is a parabola, and I know that it's actually a horizontal parabola because my y term is being squared. So to put it into standard form, I'm going to complete the square here, and I'm going to also factor out the 5. So we have 5 times y prime squared plus 2y prime plus something. I need to complete the square here. And I'm going to move my x term to the other side, -5x prime minus 1. So I can see here the number that would complete my trinomial is 1, but it's actually like I'm adding a 5 to both sides. So let's simplify. Here I'll have 5 times y prime, I don't need those parentheses, plus 1 squared. And then here I have -5x prime plus 4. Now remember, for standard form, we're going to want to move this to the other side. So we have y prime plus 1 squared equals -x prime plus 4 over 5. And then the last thing we're going to need to do is factor out the -1 here because it's not quite in standard form. So we have y prime plus 1 squared equals -x prime minus 4 over 5. Now this is in standard form. I want to remind you guys that standard form should look something like this. Y minus k squared equals 4p times x minus h. So looking at this, I can see that the vertex of our graph is at 4/5, -1. I can see that our p-value is -1/4. So that means that to get to our focus, I'm going to add -1/4 to our x value because I actually have a horizontal parabola. So here I know that my focus is going to be at 3/5 -1. Now I do want to remind you guys, this is all in terms of the x prime, y prime axis. So let's see if we can graph this. Here's our xy axis. Remember, we determined that our angle of rotation was about 26.6 degrees, so we'll just estimate where that would be. Okay, I'm going to give myself some scale. Okay, so our vertex is at 4/5 -1. So that's going to be right around here. So remember, I'm going 4/5 and then -1. So once again, 4/5 -1. I'm graphing it in terms of my x prime, y prime axis. I know that it's going to be a negative parabola. So it's going to look something like this. And then I know that my focus is right in here close to my vertex. And there you have it. So just be careful that your equation is fully in standard form, even if it's something as small as factoring out a negative, because you do need your equation to look like this to determine your vertex and your p-value to find the focus. Okay, that is all for today's lesson. Thank you so much for watching.